Hey everyone and welcome. Today we're jumping into a topic that is absolutely essential for any Linux admin, making sure your file systems mount correctly and reliably, every single time. You know, if you get this wrong, your server might not even boot. So let's dive in and make sure that never, ever happens to you.
All right, here's the game plan. First, we'll talk about a super common problem that can easily take a server offline. Then we'll get into the solution that guarantees stability, UUIDs and labels. After that, we'll look at the classic way to automate mounts using fstab, and then compare that to the modern, more powerful approach with systemd. And of course, we'll wrap it all up with some key best practices you can start using right away.
So let's kick things off with a really frustrating issue. It's something pretty much every Linux admin runs into at some point, the unstable device problem. I like to call it drive hide and seek, because that's exactly what it feels like. Okay, so picture this, right? You've just done some routine maintenance, you hit reboot on the server, feeling good, and then nothing. It just doesn't come back up. You finally get a console open and see that dreaded error message, a critical data drive failed to mount. This isn't just a made-up story, it's practically a rite of passage for a lot of us when we're starting out.
So what in the world is going on here? Well, the problem is that those device names we're used to, like /dev SDA, SDB, SDC, they aren't actually permanent. The Linux kernel just hands them out as it finds drives during boot, and on order can change. So if you plug in a USB stick or add a new drive, the names can get all shuffled around. Your data drive might suddenly become /dev SDC, but your system is still trying to find it at /dev SDB, and poof, the mount fails and your boot process grinds to a halt.
Thankfully, there is a much better way to handle this. We just need to give our file systems a permanent address, something that doesn't change no matter what. And we do that using stable identifiers. First step, and the most rock-solid option, is the UUID. That stands for Universally Unique Identifier. It's this long string of numbers and letters that gets permanently burned into the file system itself when you format the drive. And here's the key. It is statistically guaranteed to be unique across every single device on the planet. It will never ever change unless you reformat that drive. Our second option is a label. This is just a friendly, easy-to-read name that you can give to a file system yourself, like My Data or Backups. It's way easier to remember than a UUID, for sure. But you gotta be a little careful, because unlike a UUID, there's nothing stopping you from accidentally giving two different drives the exact same label. I love this analogy, it makes it so clear. Think of a UUID like a social security number. It's totally unique, it's permanent, and you use it for all the official important stuff. That's why it's perfect for your root partition or your home directory. A label, on the other hand, is more like a person's name. It's easy and convenient, but you might know two people named John. That makes labels great for things you're plugging and unplugging, like USB drives, where you just want a simple, memorable name. So how do you find these magic IDs? Well, the lsbkf command is your absolute best friend here. Just run that, and it'll show you all your drives, their file system type, any label they have, and that super important UUID. Another great command is blockade, which gives you similar info in a slightly different format. Either one will get you what you need. Okay, so we've got our stable IDs. Now let's look at the classic, the time-tested way of telling Linux what to mount automatically when it boots up, the etc/fstab file. Now, this fstab file might look a little cryptic at first, but it's really just a simple table with 6 columns. The first field is the most important one for us right now. It's what to mount. And this is exactly where we'll put USUID or label equals. The next few are pretty straightforward. Where it goes, what kind of file system it is, and any special options. And those last two, dump and pass, they're mostly for older backup and file system check tools. Honestly, you'll almost always just set them to 0. Here we go, a perfect real-world example. Instead of using something unreliable like /dev/sdb1, this entry uses label equals home disk. This tells the system to find the drive with that specific label and mount it at /home. It's simple, it's readable, and most importantly, it's not going to break on a reboot. And this quote from the LPI learning material just nails it. The whole secret to avoiding those boot time headaches is to use an ID that's part of the file system itself, the label or the UUID, not some temporary name the kernel just decided to use that day. But you know, fstab isn't the only game in town anymore. On modern Linux systems, we have an even more powerful and flexible tool we can use: systemd mount units. On pretty much any modern Linux distro, systemd is running the show. It manages almost everything, and that includes mounting file systems. So think about this. What if you need to mount a network drive, but only after the network is actually online? Or what if you want a drive to mount automatically the first time someone tries to access it? That's where the power of systemd with its .mount and .automount units really starts to shine. Now, I know this might look a little more complex, but it's actually really clear once you see it. Check out that mount section. You've got what, where, and type. Sound familiar? They map directly to the first 3 columns of fstab. And get this, systemd is so smart that it actually reads your fstab file when you boot and creates these mount units for you in the background. So by creating your own file, you're just taking manual control for those more advanced situations.
And getting one of these up and running is a pretty simple 4-step process. You create the file, and the name is really important. It has to match the mount path. You put it in the right systemd directory, you tell systemd to reread its files, and then you enable it so it starts automatically. That last command, systemctl enable, is the final piece of the puzzle. It's what makes the whole thing persistent. What it's actually doing behind the scenes is creating a little shortcut, a symbolic link, that hooks your new mount unit right into the boot process. It ensures it gets started up every single time.
Okay, that was a lot. We've talked about the problem, the tools, and a couple of different ways to get the job done. So let's boil it all down into a clear set of best practices for you to follow.
All right, let's lock this in. For anything that's critical for your system to even boot, like your root, home, or boot partitions, always use UUIDs in your fstab. For removable drives or data drives that you manage by name, labels are fantastic. If you have a more complex situation, like a network drive that needs the network to be up first, that's a perfect job for a systemd mount unit. And please, I can't say this enough. Before you ever reboot after changing fstab, test your work with a command like mount-a to make sure you didn't make a typo.
So there you have it. You now know how to get away from those fragile old device names and build Linux systems that are truly robust. The next step is all you. Fire up a virtual machine, play around, find the UUIDs on your system, try editing fstab, maybe even try to build your first systemd mount unit. The best way to learn is to get your hands dirty in a safe place. Thanks so much for tuning in.